You've seen this. You clone a repo from GitHub, run npm install, and suddenly your terminal looks like a crime scene. Every day we run npm install or pip install and just hope it works. And when it doesn't, we delete node modules, clear the cache, maybe restart the computer for good luck, and try again. Package managers aren't random. They're not chaos. There's logic behind every success and every failure. Once you know it, you'll not feel helpless in front of that red text again. Let's fix that. Let's start simple. You're building an app. You need a library to format dates. One command, one package, easy. Except you didn't install one package. That one package had dependencies. Those dependencies had dependencies, and those had dependencies. Think of it like hiring a contractor. You hired one contractor for a simple job. They brought subcontractors who brought their subcontractors. Your simple job now involves 50 people you never interviewed. This isn't unusual. A typical NPM project can easily have hundreds, sometimes over 1,000 packages in this hidden tree, all from installing maybe 20 things yourself. This has already happened. In 2016, a developer unpublished a tiny package called leftpad from NPM, 11 lines of code. Within hours, React broke, Babel broke, thousands of projects that depended on them, including builds at major tech companies, ground to a halt. Global chaos. From code that could fit in a tweet. This web of packages is called your dependency tree, and managing it, figuring out which versions of everything can coexist peacefully, that's the actual job of a package manager. The install command? That's just the surface. There's a language that will save you hours of debugging. Every version conflict error is written in it. Once you speak it, those red walls of text become obvious. The language is called semantic versioning, or semver. Patch, the last number, bug fixes only, nothing should break. Minor, the middle number, new features added but still backwards compatible. Major, the first number, breaking changes. Things might need to be updated. Your code might not work anymore. This shows up in your package.json. Open one and you'll see version requirements like this. That little caret symbol, that's not decoration. It means, give me version 4.17.0 or any higher version, but don't you dare cross into version 5. You're saying, I trust anything within major version 4. Minor updates, patch updates, I'll take them. Just don't give me version 5. It's a big target, flexible, easy to hit. But what if you write the version with no symbol at all? Exact version, tiny bullseye, no flexibility whatsoever. You get precisely 4.17.21, nothing else, forever. The challenge, your project has 50 packages. Each one declares its own version requirements, its own target zone. The package manager has to find versions that land in everyone's green zone simultaneously. Sometimes, there's nowhere to land. Picture a version conflict as a scheduling problem. Package A needs shared library version 3.0 or higher. Think of it as only available from 3 p.m. onwards. Package B needs that same shared library, but version 2.x only. It has to leave by 2 p.m., can't stay later. Now, the package manager needs to schedule a meeting where both can attend. It scans for overlap, looks for any time slot that works for everyone. There's no overlap. No version of the shared library satisfies both requirements. Package A needs 3.0 or higher. Package B can't go above 2.x. These ranges don't touch. This is a version conflict. NPM tried to schedule the meeting. It's mathematically impossible. That wall of errors is NPM telling you, I tried. There's no solution. These two packages cannot coexist. Now, modern package managers have workarounds. NPM can actually install the same package multiple times at different versions, nested in different parts of your project. It's like scheduling two separate meetings instead of one. Not elegant. Your node modules folder might have duplicates of the same library, but it works. Python's pip historically couldn't do this trick. Python's import system only allows one version of each package in your environment, period. Which is why Python dependency management has been historically painful. Tools like poetry have improved things, but it's still fundamentally trickier than NPM. So, version conflicts are inevitable in any real project, but there's one file that prevents most of the works on my machine disasters. And many devs don't understand what it actually does. Two developers, same project, same package.json, both run npm install on the same day. Do they get identical results? Without a lock file, probably not. Remember, caret 4.17.0 means 4.17.0 or higher. If a new patch version released at noon, the afternoon developer gets it, the morning developer doesn't. Same package.json, same commands, different actual packages installed. And now you're living the classic developer horror story of works on my machine. Bugs that exist on one computer but not another, tests that pass locally but fail in production, hours of debugging something that isn't even your code. This is why lock files exist. Think of it like a recipe. Your package.json is a casual recipe. It says, add Lodash. Your lock file is a laboratory formula. It says, add Lodash 4.17.21 with these exact subdependencies at these exact versions. When NPM sees a lock file, it doesn't solve the puzzle fresh. It doesn't check what's newest. It reads the lock file and installs exactly what's recorded. No guessing, no variation, identical results. Deterministic builds, reproducible results. This is your guarantee. Every serious package manager has a lock file. NPM, Yarn, PNPM, Poetry, Cargo, all of them. One rule, non-negotiable. Always commit your lock file. I see repositories with lock files in .gitignore constantly. People think it's generated noise. It's not. Your lock file belongs in version control. It's the only thing guaranteeing that your code works the same way on every machine, every server, every deployment. This wall of errors isn't random noise. It's a detective's report. Every clue you need is here. First line, resolve unable to resolve dependency tree. NPM tried to find a valid combination of versions, couldn't do it. Next, found React at 18.2.0. This is what you have installed, React 18. And peer React at 17.0.0 from some UI library at 2.1.0. This package, some UI library, has a peer dependency. It's saying, I need React 17, you have React 18, we have a problem. The conflict is spelled out, React 18 versus a React 17 requirement. These cannot coexist. Read these error messages like a detective. Look for found, that's what you have. Look for peer, that's what something else demands. Find the mismatch. Two mistakes I see constantly. Mistake 1, your install is broken, so you delete the lock file and regenerate it. No, stop. You just threw away the exact versions that were working. Now you're pulling in whatever's newest, including potentially broken updates you've never tested. Instead, use npm CI. It's designed for automated environments, CI/CD pipelines and such. It deletes node modules completely and installs exactly what's in your lock file. Clean slate, reproducible. This is also what you should use in CI/CD pipelines, not npm install. Use npm CI, faster, stricter, reliable. Mistake 2, peer dependencies are a package saying, I need you to install something specific. I won't install it myself. When you ignore these warnings, npm might force an installation anyway, but you're setting yourself up for runtime crashes, weird bugs, components that just don't work. These warnings predict future pain. Don't scroll past. Bonus disaster, your dependencies are 2 years old. They still work. Why update? Because security vulnerabilities are discovered constantly. You're running code with known exploits that actively target. Run npm audit regularly. It scans your dependencies for known security issues. Better yet, use tools like Dependabot or Renovate. They'll automatically open pull requests to update vulnerable packages. Set it and forget it. 4 rules. Internalize them. You'll avoid most of dependency disasters. Package managers aren't magic. They're not random. They're solving a hard problem, fitting hundreds of puzzle pieces together when every piece was made by different people at different times with different assumptions about how the world works. You see the logic now. You understand why version conflicts happen. You know lock files aren't optional clutter. They're your safety net. You can read an error message and know exactly what's wrong. You're not guessing anymore.